Hello everyone, this is Team Iris, myself Avijit and my friend Debrina. Today we will be presenting SICPI, a smart IoT connected plant incubator.
Starting with the problem statement, one might ask what is the need of plant incubators? Well, different species of plants have different kind of requirements for growth. It's often difficult to provide the right condition for a plant to grow in an open environment. By right conditions, we mean the right amount of soil moisture, air humidity, temperature, light, soil, pH, etc. that needs to be present in the environment with balance for that particular plant. With that being said, we have to monitor them constantly, hence, an incubator is required.
Now, the conventional incubators require tedious amount of manual monitoring and also they are quite expensive. The high cost of maintaining a controlled growth environment is often a limiting factor when determining the experiment size and feasibility.
SICPI, which is unlike the native ways which required human labor to perform monitoring, in SICPI we implemented IoT capability to perform the real-time monitoring using low-power hardware and lightweight software. Along with monitoring feature, it will also include a closed-loop feedback control for maintaining the parameters with a fast response time. Now moving on to the demo and the prototype.
So here is SICPI. Now it's connecting to Wi-Fi. It gets connected to the Wi-Fi, and now it starts to connect to Akiro. It's connected. Now the status of the controller is inactive, waiting for the response from us to set the desired temperature and the moisture level. Along with that, publishing the data to the real-time values in the Akiro dashboard as well. Next, we will move to this demo video. Here is our setup, and on the left we have the Akiro dashboard already set up by us. The current screen is messaging dashboard ready to connect to SICPI and perform the messaging over the MQTT protocol. With that being said, we have the plant kept in the bucket. We use the bucket to emulate the chamber. The parameters will be monitored by the sensors, that is the temperature, humidity, soil moisture, and the CO2 content in the air, and to actuators for controlling them. Along with that, we have an OLED display that will be displaying the real-time parameters over it. Starting with the pump here, which will be able to pump the water from the small bucket, and we have colored the water to show that water is flowing inside. To control the temperature, we will be using a 100-watt bulb which will provide the heating. Now the sensors, here is DHT11, the temperature and the humidity sensor, and here is the MQ135 air quality sensor which will provide the CO2 level inside the chamber. And finally two relays here that will be used to drive the motor pump and the bulb. Okay. Oh, down below there is a soil moisture sensor that will be reading the moisture from the soil. Anyways, now we will be activating the controller. For that, Deblina will be setting up the MQTT connection from the dashboard. And yeah, she is doing it from her place, so no local IP thing. After connecting, she will be entering a few instructions whose syntax we have defined to change the set point of the temperature and the moisture as well. After setting it up, the controller will start performing its automatic control action. Basically, we have implemented a P-type controller. So, Debina, can you please set up the thresholds for the to start the controller? The acknowledgement and the parameters will be getting displayed on the Akido's dashboard while dumping the data as well. So now we can see the bulb has turned on since she has changed the set point of the temperature to a higher value than the ambient one. Also we can see to retain the soil moisture, the pump has turned on as well and the water is flowing inside. As soon as the soil gets enough water, that is the moisture, the uh, desired moisture level, the pump turns off automatically. And I think it has turned off right now as well, since it has reached that temperature. Also, we can see the real-time temperature, humidity, and the CO2 content in the OLED display as well here. And the values. Oh, okay. So it seems that the ambient temperature reached the desired temperature. So it turned off the bulb. And this cycle will repeat to maintain this parameter over and over again. I hope you liked our video.
This is the business model we have presented here, and the Canva shows all the crucial points that are required for our marketing.
Thank you.
Thank you.